All right, Swiss Army knives. It's supposed to be a metaphor for a game engine. There are many things wrong there, right? It's the thing I liked you to remember from this slide is that apparently you can list everything in a knife, right? And by listing these things, you feel like you can use it and you can combine them and it's just perfect. That's not the case, right? A game engine is certainly not a perfect thing. So let me, yep. Okay, background, me first. So I've been there for a while. As you can see, I started with a slide rule, doing mechanical engineering, manufacturing engineering. That's CAD/CAM, computer-aided design and computer-aided manufacturing. Robotics was a long time ago, 1978. You can imagine what robots were at that time. Then I moved because luckily I was able to be a student at Berkeley, and I thought computer science was much more interesting than manufacturing engineering. And then I moved to Stanford for AI at the robotics lab, where I discovered planning. And you can see that I'm still a planning guy. AI planning research, everyday life planning. Game AI planning analytics, entropy and behavior analytics. These games here, I've been able to get in-game data from all these games. I'm really, I was not working for them, it's just I just knocked there and with my enthusiasm, I said, okay, give me some data, and luckily you can see I've been able to get some data. Several things I want to mention here. Tomb Raider. Tomb Raider was released in November, and I got data, very first one, right here, from Crystal Dynamics. And I was able to get data in the alpha version of it, of the planner. It was extremely interesting to observe that the planner was fully functional in the vertical slice. And a very interesting thing also was River Peak. I don't know if anyone knows River Peak, but it was a great game, online game. And this time I knocked way before the game was released as well. It was 3 months only. Solomon Slavinsky said, okay, we should be starting something like December. And they had 3,000, it was an online game with 3,000 or 4,000 connections a day. And the game ended in February with 3 or 4 million connections a day, and a planner was behind it for the AI. It was an amazing journey for me. 2 games there. That's the behavior analytics. Sorry, I'm not. I hope I'm not too long about that. But Doom doesn't use any kind of planning, and Solasta as well. But it's behaviors, right? Finally, you can find plans in Doom as well. It's extremely strange. So I'm still a planning guy these days, but I moved from academic to the industry. And what I do on a daily basis is dynamic grid motion planning. Okay, so the context. So I work for Hawkswell. Hawkswell is just a new studio in Paris. And I do there, again, dynamic grid-based game has yet to be announced. So I won't be able to show you many things. Sorry for that. Another context, we're using Unreal and we're using Recast. Actually, I just discovered for that talk that Recast had an icon, that icon. I'm using Mathematica. I've been using it since Stanford in 1989 for any kind of AI prototyping, really. And for this talk, I decided I'll use an LLM. And instead of using, I don't know if anyone knows Mistral AI, but I thought it would be much more fun to use Mistral than anything else. Okay, so let me show you 2 videos of the game. They're old videos, but they should state the problem I'm working on, okay? This one, I hope it should, so Unreal, inside, editor. Okay, so you see this NPC jumping. So the problem there is that you should, but we should be able to find jumping position automatically. And just think of it that this very big right here, I'm sorry, I'm used to a laser, but this platform wasn't there a few turns ago, a few minutes ago, and maybe this one is going to disappear. So let me show this one now, this video. So there is a kind of abyss or a big hole. Just imagine that the hole wasn't there, or the abyss wasn't there a long time ago. Everything is dynamic again. Maybe the tree can burn, or maybe you can push those pillars over the abyss and you can jump on the pillars to cross the abyss. So how can you do that, all this dynamic thing? And what I learned is that you can trust game designers for being extremely creative in terms of dynamicity. So, dynamic motion planning, what does that mean? Well, to me, it means two things, right? You just cannot do it from scratch with Unreal. That's my position. And this talk is much more, it's the end of the day. It was not scheduled at the end of the day, but then for those who attended GDC, you know, at the end of the GDC AI Summit, at the end of the summit, there is a rants and rave, and that's pretty much what I'm doing. I'm defending the fact that you should use other tools and simpler tools just to complement what you want to do, okay? Don't use Unreal and Recast alone. And here, what I'm going to do is use Mathematica and Mistral AI, just for fun, for this talk only, and analytic geometry. Okay, so analytic geometry is your friend. What I just observed, what I've been observing is that people are going away from math, really. We're not using math anymore, really. People are afraid of equations, and each time I say, okay, maybe I could write this equation. Well, my game designers, okay, you say game designers and math. No, it's more. Even my fellow programmers, they just say, are you sure you want to do this, Eric? Yes, I want to do this. I want to write down an equation and solve it, and to be extremely accurate. And believe me, I can do it on time. That's when I'm speaking to them, okay? So anyway, I do understand that maybe analytic geometry is a problem. Let's rephrase that and say, how much accuracy do you need? Okay? So to answer that question, let me rephrase again, what is a game engine? And here, I'm going to use my whole background since '78. So game engine is a real-time database which happens to visualize some of its internal states in 3D. That's exactly how I see a game engine. You know, I don't know what's your take on what is a game engine, but to me, it's only a real-time database, period, okay? If you look at what is a game engine architecture, you get from the foundation, very first chapters of the book, you know, parallelism, concurrent programming, the real-time side, and math, okay? The prior chapter are not really related to programming and game engine. It's pretty much more the social way of programming, right? And visualizing internal states in 3D, it means vector spaces, Euclidean spaces, orthonormal frames, all the time. So I guess you do know those, right? That's what they're doing. Avionics, that's a train, that's a control room. I remember that was 25 years ago. I came to discuss with a friend teaching real-time systems and discussing game engines and games, and he said, wow, you are discussing about avionics. Wow, really? I'm discussing about avionics? Okay, let's have this one. Yes, we are discussing about avionics as well, okay? And the big difference there that you must have in mind, it's that on this side right here, a crash means death. Of course, death in a game engine, it's just your NPC, okay? Just your asset which crashes, and it's not very, it's not much of a problem, right? It might be even fun if you're fighting. But that's exactly what happens. It has to be accurate because otherwise it means death. Please do keep this in mind. And okay, virtual future control room, and I put this one because of the NPCs and the AI that are there in the control room, okay? So real-time database. So to me, it started as live support system, okay, interactivity support system, immersive support system, flow support system, and fun support system. And that's where we are now, game engines, okay? Game engines are fun support systems. But they trace back to live support system. That's anyway how I see it. Okay, let me give you, grid, okay, yeah. Let me give you dynamic grid motion planning use cases. Okay, very first, fallen pillar, remember the pillar. Okay, this one is moving. Okay, another one. Where are conic area of effect tiles? One cone isn't tile-centered. You can see the cone, so the center of the cone isn't right in the middle here. So you can move it anywhere here. So where are the tiles? It means that computing them, pre-computing them is difficult. And last one, okay. Shooting line, what's the impact level for each tile? If you have a target, yellow target, and you're shooting, there is a line, and all those 3D tiles are impacted differently because only a small portion of the line goes through the cubes. Okay, how can you compute all that dynamically? When you're using Unreal, sadly, I would say, the very first tool you have is EQS. You got to query or to sample the database for locations with various properties, right? You filter all that. So what you're using is generate and filter. We've heard that many times already today. Generate and filter, you filter many kind and queries as well. Querying axioms, very first talk of the day by Tim from Guerrilla. And there we query the 3D database of the engine. So let me show you an example. Okay, again from Unreal. I'm sorry, since the game isn't announced, I cannot show you the what I do for the videos, but I can show you the third-person template as well, better. That's the EQS query method. I generate a grid of points, and I filter these points with the nav mesh. And you can see the result. We have a grid 7 by 7, and they should be on the nav mesh. And I'm serious when I say they should be on the nav mesh. Okay, so the same computations here. So that's the exact computation right here, not the one from Unreal. I'm going to show you the result from Unreal. Okay, recast, I mean, but Unreal. Okay, there is no nav mesh here. Okay, so the line is red. Okay, there is a nav mesh here, it's green. So the line is green. So everywhere, anywhere it's red, there is no nav mesh. So we shouldn't be able to project points exactly here. Okay, let's see what Unreal is doing. So you get a point here and you say, okay, it's not that bad. Because it's still on the nav mesh. Well, not really. It's a little outside of the nav mesh. Okay, and you can see here you get points everywhere. Unreal was able to project points everywhere and behind. And let me zoom in to show you where the problems can lie. So it's on the side of the nav mesh, and the problem is that since I'm using a grid, then those points may not be on a grid. Let me show you that. So, hop and hop. So that's terrible here. Quite terrible, right? That's a EQS query. I would like to get points only on a grid, but that's not what Recast is doing. Recast just returns back some points outside my grid or not aligned at all. You can see that. It's rarely, this one is just amazing. This one as well. You have points everywhere, almost. You have some points on the grid, some not on the grid. Let me give you another view of it. Okay. So 2 slides ago, we were on the other side of that platform. All right. And you can see right in the middle here that you get points everywhere, and I'm quite unable to build a grid from that. And since my game is dynamic grid-based, then how can I build a grid? So the very first answer is, okay, Eric, no problem. We will recenter all the projected points using an algorithm. No, we're not. We're not going to do that because some are outside the green you are projected. So how do you center something which is outside what you want? So it's difficult, and the solution is then, okay, what I'm going to do is query the very low level of the nav mesh. The very low level of the nav mesh is the nav mesh triangles, and compute exactly the equation of each nav mesh triangles, where I am projecting the points, and then if my point is within that triangle right here, okay, I got a result. If it's not, it's red. Okay. So do not solve this yourself, okay? That's what I would advise. Instead of generate and filter, what we should do is we should move from EQS, environment query system, to equation query solving. Of course, you can come up with many words for which still have E, Q, and S for the first letter, but that's the idea, right? Please do trash, generate, and test, despite Unreal really provides any tool to do that. So how do you do equation query solving? Let's get back to analytic geometry. I did not explain what analytic geometry is. I'm not going to explain it, but I'm going to show what it means. Okay, so finding back the triangle means solving these equations. Okay, obviously, that's why I wrote on the slide before, do not solve this yourself. Okay, just use, and here I use Mathematica to do this. You can see that the very first number is 0.3588. It's the second, okay? So it's a third of a second to solve the very first line, the call to reduce. And we're solving this okay, right here, this equation, and that is analytic geometry. Analytic geometry is writing, transforming 3D components into equations and solving it, okay? And I give you an example here, S1, S2, S3. So S1 is X1, Y1, Z1, S2 is X2, S2 is yes. And S3 is X3, Y3, Z3. And A, B, C, D, where are they? They are the coefficients of the plane you are computing. You see that brown plane right here. It has an equation. It is within a plane. In general, we call that a hyperplane. And we have 4 parameters, and that's what we're doing. So if you notice, we have 4 variables and only 3 equations. And so it's a problem. So we need more, again, things to solve all that and have solutions. Nevertheless, I'm not going to dive into how to solve all that. I'm going to show you all that. An example you can do in Mathematica. Runtime is 11 seconds for 400,000 points generated with edge cases. You can see edge cases here, edge cases there. Just one line here. Can you project on a line? Recast cannot, but from time to time it can. It's very strange. And again, it would be impossible to do this really in C++. I can assure you it's just, it takes me, what, half an hour to write that, 10 seconds to get a solution. Well, use a tool. I decided just for the fun to use MathGPT and ask him to solve the problem with the metrics. This solution is correct. I used Mistral AI tied with Mathematica just to go a little further. This time you get the code in Python. Solution is correct. And I decided to, okay, give me the code in Mathematica. I didn't check it. I think it's correct as well, but I'm not sure. Anyway, never hesitate to ask your friends. Accurate geometry is equation query solving. Nothing more, nothing less, okay? And I use Mathematica, but you can use MATLAB as well. You can use Sage. Sage is an open tools. It's free. You could use Python with Jupyter Notebook if you wish. I use Mistral AI here, but you can see that you could be using with Mathematica any other LLM if you don't want to solve the problem yourself by hand. And you can have fun. So real-time equation query solving is within reach, okay? We move from how much geometric accuracy do we need to what can we achieve with the best possible accuracy. I suggest you spend some time prototyping with your tools. You organize the computation carefully, something I didn't discuss at all, which means using all the parallel computations your engine can provide to organize the computations and have it get the results in no time. And I guess that's it. Thank you for your attention.